another kind of two-dimensional data structure. Lost my chalk again. Behind me. Thank you. Another kind of two-dimensional data structure is a deep list. My favorite example this is not a tree like those ones I drew on the board, because it's not a sort of infinite depth kind of thing. It's a list of lists of words, or in other words, a list of sentences. Okay? And ordinarily, I would write a program to manipulate a list like this by using car encoder for the elements of the outer list, and first and but first, probably, for the elements of the inner list, because I'd say those are sentences. All right? But right now, I want you to kind of squint a little, look at it sideways, and say, this is kind of like the following tree. Okay? See the connection between this picture and this picture? Now, this is a funny sort of tree. It isn't like the trees we've been dealing with, because the branch nodes in this tree don't have data. So there's a very sharp distinction between a leaf node, which has a datum but no children, and the other nodes, which have children but no datum. Okay? So it's not an example of the abstract tree structure that I built a few minutes ago. But it is a tree-like thing. And we can use tree-like code to manipulate it. So if I wanted to do something to every word of this thing, and I wanted to figure out how to do that, one approach I might take would be to write something that looks a lot like tree map. Except that it wouldn't talk about make tree or datum or children, because we're not using that abstract data type. Instead, it would say, this. And what this code says, it's not as pretty as tree map, but it's not too bad. It has an if. For tree map, for every node, we have to do something to the datum and also do something to the children. In this kind of deep list, a node has only a datum or has only children, depending on whether or not it's a list. If it's a list, it has only children. So I do this thing, which calls deep map by way of map, just like tree map called tree map by way of map. But instead, right here, whoops, where it used to say children of tree, here it just, oh, LOL, by the way, it does not stand for laugh out loud. It stands for list of lists. So you kind of want to be seeing children of LOL here. But a branch node is its children. A branch node is just a list of its children. So there's no selector needed for finding the children of a branch node. A branch node is a list of children. And at the other end of things, if it's not a list, then it's a leaf node. And the leaf node is just its datum. So instead of calling fun of datum of LOL, we just call fun of LOL. All right? So in tree map, every call involves both of these pieces. In deep map, there's an if. And we do only the thing for the datum or the thing for the children, not both. And that applies to the whole node. All right? So that's what you get by kind of squinting your eyes at a deep list of lists. And it could be a list of lists, and this mechanism would still work. It could be an arbitrary depth list of lists. Okay? So it's better than something that you would write just for lists of sentences. List of sentences one might be easier to read for this particular situation, but this one, this deep map, works on lists of sublists of sub-sublists of sub-sub-sublists to varying depths and varying places, however you want, just like trees can have varying depths. Okay? So, just to make your life unbearably complicated, okay. The book, confusingly, uses the word tree to mean what I'm calling a deep list. I use the word tree as a broad generic term for any of these two-dimensional data structures, including the list of lists, the capital T tree, the binary tree, any other 2D structure that we come up with where each node has one parent node, or except for the root node. Okay? So me, this is a generic term. Them, they mean deep lists. So they have a thing called tree map that's like my deep map. Okay? Just to confuse you. When you see tree with a capital T, it means this thing with datum and children as selectors and make tree as the constructor. Okay?